out of these 10 formulas, 2 of them were true and 8 of them were false. So why do this true-false activity? So of these 10 formulas shown, formula 1 is true. It happens to be called the distributive law. But formulas 2 through 6 are examples of situations where you can't distribute. Let me just step back for a second. As you can see, formula 1, okay, true. And then these other things like distributing this exponent, distributing the square root, distributing the function f, distributing x when you have a multiplication sign here, distributing this a when you have this exponent out there. There are lots of situations when people try to distribute. Moral, not everything distributes. Of the 10 formulas shown, formula 7 is true. It's the fraction addition law, but is often confused for formulas 8 through 10, which are popular mistakes for fractions. So the moral here is we thoroughly need to understand each thing, whether that's fractions or roots and so on and so forth. Another moral, like the first moral, is not everything cancels. So we said not everything distributes. Well, not everything cancels as well. And we didn't have examples of this in the formulas that were just shown, but sometimes there's a habit of canceling things that can't actually cancel. So we need to go through these things. The point of this activity is we all have misconceptions and we need to address these things. Part of the process of learning is in fact unlearning, right? Part of the process of learning is unlearning. To learn, we need to unlearn our misconceptions. And this is true in all areas of life, not just in math. We all hold on to misconceptions. There's something great that we can do, and we can take the knowledge that we have, take a new piece of data that comes in, and somebody says, hey, here's this thing, and then you have to look to see whether that's objectively true or not. And then that might reform the way you think about some things. So when we learn new facts that can be verified to be true, we ought to challenge ourselves to ditch our misconceptions. There are plenty that everybody tends to have in a math class, and so we're going to address some of these things. So let's talk about undoing math misconceptions. The majority of students haven't thought about why the formula a times quantity b plus c equals ab plus ac is true, but why the formula x plus y in parentheses raised to the nth, why the n doesn't distribute. Why is that false? So building good habits is going to help with mathematical success. If you've never asked which formulas are true and which formulas are false, I encourage you to start now. This is not the way most students tend to think. Most people don't think in terms of these formulas, but it's going to be very helpful to know which formulas are true and which formulas are false and how to use formulas properly. Those things will be the key that will make the rest of the semester go smoothly. Now, plugging in a equals 6 and plugging in b equals x and plugging in c equals 2 into this formula here, into the distributive law, we get 6 times quantity x plus 2 equals 6x plus, and then I already simplified 6 times 2 to a 12. So the point is using this true formula. Again, we haven't discussed why this formula is true and why this one up here is false, but let's just go with it now. If this formula is true, we get this equation here, and so it is valid to replace 6 times quantity x plus 2 with 6x plus 12, and the reverse also works. It's valid to replace 6x plus 12 with 6 times quantity x plus 2. If you plug x, so let's look at this false formula, x plus y quantity to the nth equals x to the nth plus y to the nth. If you replace each x with a 4, every y is replaced with an h, and every n is replaced with a 3.6 into this false formula, you get 4 plus h quantity to the 3.6 equals 4 to the 3.6 plus h to the 3.6. Now that just doesn't work, right? So it is actually invalid to replace 4 plus h to the 3.6 with 4 to the 3.6 plus h to the 3.6, and it's invalid to replace the other way around as well. So we have to be really careful to always use true formulas and to not use false formulas. Using these false formulas, this is bogus. It doesn't work. But it's a common thing that people do, is that people will see the situation of 4 plus h quantity to the 3.6 and decide to distribute this exponent, but it can't be done. It is invalid to do that.